Hello again, math students. Today we are going to be using the Pythagorean theorem in a new way. What we're going to be doing today is using the Pythagorean theorem to find the distance between 2 points on a coordinate plane. Now, there's also something called the distance formula that is derived from it, comes from the Pythagorean theorem. We're not going to be learning about that this year, but in geometry you'll use that. And again, it's right from the Pythagorean theorem. We're going to be doing this more in terms of looking at the graph and finding those distances. So when we have two ordered pairs, for instance, I've got 3, 0 and 7, -5 graphed. I want to know the distance between those 2 points. We're going to use the Pythagorean theorem with what we know. You can see already they have a graph drawn here to create a right triangle, really, so that length that we're looking for is the C, it's the hypotenuse. So from 3, 0, we're drawing this vertical line, which happens to go through 1, 2, 3, 4, 5 squares, so that's why that side length is 5. And then we draw a horizontal, and we've got 1, 2, 3, 4 squares that way. So I'm looking for the hypotenuse of a triangle whose legs are 4 and 5. Now this isn't a 3, 4, 5, obviously, because the C is going to have to be bigger than the 5. When we're counting this, it's going to feel very similar to how we count slope. So don't be surprised if you're kind of drawing that comparison. However, unlike slope, when we have to do rise first and then run, we don't have to do it in that order for this kind of a problem. So what we're going to look at then is I'm going to substitute in the 4 and the 5. Notice that they even switched around to put the C squared first. They said if we're looking for that distance, we could put that thing first. It's just fine if you leave it as a squared plus b squared equals c squared. We know that 4 squared and 5 squared are going to be 16 and 25, which we have here, which is going to be 41. And then to figure out what c is, because I don't really care about c squared, I just want c, I would need to take the square root of both sides. Notice that they kind of went back to our old thing of putting this plus or minus right here, which is a great habit to be in. However, when we're doing these applications with the Pythagorean theorem, it's not really necessary because we're not going to have any negative lengths. So seeing that plus or minus is great. However, we're going to basically ignore the negative answer from that because in this situation, the negative part doesn't make sense. So 6.4 units. We can't just count the number of squares that goes through or anything. We have to actually do the math for the Pythagorean theorem to find this. If they give you a situation, kind of like what we've done already with applications and drawing pictures, says the park is 5 miles east of your home. The library is 4 miles north of the park. How far is your home from the library? Round your answer to the nearest tenth. So here's the picture. They just happen to put it on the coordinate plane. Now you're going to notice these are exactly the same numbers that we just did on the last slide. We know what this answer is going to be, but this one is showing you, since it is the park is 5 miles east of your home. So they said the home is right here at the origin. 5 miles east would be 5 squares, and then the library is 4 miles north of that. Again, when we use those cardinal directions, we can assure that we've got a right angle right there. So we could substitute again the 4 and the 5 in there. It's the same numbers, so it's going to be the square root of 41, which we found to be about 6.4. So if you would go from your home directly to the library, hoping that there was a road that went straight there, it would be about 6.4 miles. This is more of what your problems are going to look like today. In fact, that distance won't be drawn in. We'll just have 2 points on the graph. You'll have to draw that. Now, I need to create the right triangles. So you can only draw, after you've got that segment drawn in, you can only draw horizontally and vertically. So when we're doing this, again, I don't care which direction you go first, but to make a right triangle, that was not very straight for that side, that's what I have to do. Please don't try to draw something in like, oh, I'm going to go down here and then over to there. Like, it has to be just horizontal and vertical, or the Pythagorean theorem doesn't work because we've got to be able to get a right angle. Now that I've got this graphed, and remember, you could draw that triangle that I have there, or you could draw this triangle over here. It's the same dimensions. It's really just the diagonal of a rectangle now. But this is 1, 2, 3 squares across that way. And you can even see I've got this numbered, but 1, 2, 3, 4, 5, 6 here. To find that diagonal, we're just going to use the Pythagorean theorem. So 6 squared plus 3 squared equals c squared. That's going to be 36 plus 9. And 36 plus 9 would be 45. And the square root is what we're going to need because we have to undo that square. So the square root of 45 is about 6.7. I kind of ran out of space, but I also have the answer right there. 6.7 units. We don't know if this is measured in inches or meters or feet or whatever. These are just squares on a coordinate plane, so we're just going to call them units. On the worksheet, I don't really care if you label each of these distances because they're all going to just be units. For number 2, I'm going to draw my triangle kind of above this diagonal line so I don't go through my answer that I have right there. But again, I'm just going to go vertically until I'm level with the other one. And then there's the horizontal. So this is 1, 2, 3, 4. And this is 1, 2, 3, 4, 5, 6. So similar to the first one, but instead of a 3 and a 6, we've got a 4 and a 6. So it's going to be a little bit more. So I will have 4 squared plus 6 squared equals c squared. 16 plus 36. And that's going to be 52. And again, I don't want c squared. I just want c. We don't need the negative answer here, but the square root of 52 should be 7.2 units. For number 3, actually, I'm even going to tell you 3 and 4 are going to be exactly the same dimensions. Let me just draw this triangle. This is 2, and this is 1, 2, 3, 4, 5. So it's 2 and 5 for the legs. Let's take a look at 4 before we do number 3 because they're going to be the exact same work, but I'd like you to see one where you have to do the graphing here. So for 6, 2, remember, when we're graphing ordered pairs, we go sideways first and then up and down. So 6, 2, 1, 2, 3, 4, 5, 6. 2 is right here. And then 1 sideways, 0 up and down is right here. This time I'll draw my triangle, I guess, above because I didn't do that on the last one. So this is 2, and this is 1, 2, 3, 4, 5. Exactly the same dimensions, right? I'm trying to find that length. So we don't need to do the same work twice, but both of these answers are going to be exactly the same. The points started in different locations, and we're still going to get the same distance because it's still that same ratio between those side lengths. So 2 squared plus 5 squared equals c squared. 4 plus 25, which is 29. I'm going to rewrite that because that's going to bother me that I messed up. 29 equals c squared, and then we'll do the square root of that. So the square root of 29, I'm hoping that by now you guys are getting pretty good at estimating what this should be. We know that it's bigger than 25, which would be, the square root would be 5. 36, the square root of that would be 6, so this is in between there somewhere. This would round to be, now this one is 5.385. When I round to the nearest tenth, that's going to be 5.4 units for each of them. So I hope that that makes sense. The big important new thing today is drawing in the right triangle. The numbers that we're going to give you will be the points that we'll give you will be the diagonal, the hypotenuse, and you have to draw in the right triangle to make that work. Now, before I go on to the last slide, I want to mention that on the worksheet today, you're going to have some problems that don't need the Pythagorean theorem. And I'm hoping that you'll recognize those. Anytime I give you a segment, it's either a horizontal or a vertical segment. So for instance, if I gave you this point and this point, And I said, what is that length? Please don't try to draw in a right triangle because you can't draw only horizontal and vertical and have that length. So this is just count the squares, 1, 2, 3, 4. That's 4 units long, right? Don't get tricked on those. The whole worksheet is about finding the distance between 2 points. Occasionally we get horizontal and vertical segments. Count those. The rest of them, if it's a diagonal at all, you'll have to do the Pythagorean theorem. So today's worksheet is finding distance on a grid. The answer keys in Schoology, just like always. Please, I know that you're getting really good at doing this on your calculator. Please still show some work on your paper. And then when you're all done, do the learning check in Schoology. Feel free to graph any of those on your own paper if it's hard for you to see stuff just on the computer. If you want to write it down on paper and graph it that way, feel free to do that. If you have any questions, let me know.